Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Alright, this is the interesting problem we have been talking since 2 videos. Before we move on to this video is the continuation of the previous video. And if you have not watched the previous video, I highly recommend to watch that video, come back here and proceed to this video. Moving on. So just to give you an idea, let me recall this problem once again for you. So in this problem, we are given an array of stock prices of upcoming 6 days. You can see that these are the stock prices of upcoming 6 days. On day 0, stock price is 7. On day 1, stock price is 1. On day 2, stock price is 5, so on and so forth. And what is our task? Our task is to maximize the profit. So it means we have to buy and sell stocks in such a way that we can make maximum profit out of it. And we are allowed to do multiple transactions but not allowed to engage in multiple transactions simultaneously. It means we can buy stock on day 1 and sell it on day 2. And again we can buy stock on day 2 and sell it on day 3. But we cannot buy stock on day 1 and again buy stock on day 2 and sell it on day 3. Means we cannot hold stock in our pocket. Okay. So in previous video, we saw the iterative approach to solve this problem, and we have successfully solved this problem in big O of n time complexity and big O of 1 space complexity. Moving forward, what is the agenda of this video then? So as you can see that this is the code we have written in the previous video to solve this problem, and this code looks pretty lengthy. So what we are doing in this video, we are going to optimize this code using some other approach, okay? And we will make this code shorter and elegant. Okay, clear. So in previous video, we saw this approach of valleys and peak. What we did, we plot all the data on the graph to graphically represent this data so that we can analyze this data and get some idea. So we found that if we get all the valleys and peak, then we can book our profit and make it maximum. So here you can see that we have 2 valleys, 1 and 3, and we have 2 peaks, 5 and 6. And if we subtract 1 from 5 and 3 from 6, we make a profit of $4 here and $3 here, and it makes up to $7. So this is the approach we have followed in previous approach. Now if you look at this data, you can see that the stock prices is fluctuating alternating day. Means one day it is low, another day it is high, one day it is low, another day is high. But what happens if we would have got data like this, 7, 1, 2, 3, 4, 5, 3, 4, 5, 6, 1. And if you plot this data on the graph, you can see that here the price of stock is 7, then it went down all the way to 1, and then it keep going up and up and up till 5. And then again it went down and again it is going up all the way till 6, and then it again went down to 1. So if we found peaks and valleys in this representation, we see that 1 and 3 are valleys and 5 and 6 are peaks. And if we subtract valleys from peak, we get 4 and 3 as our profit. And if we add both the profit, we are finally making profit of $7. So basically what we are doing in this approach, we are first finding the lowest price of the stock, and then we are waiting for this stock to go up till some point, till it reaches its maximum price, okay? And then we are selling this stock, correct? So now if I tell you that instead of waiting for a stock to go up, and if we only consider shorter interval instead of these longer interval, then what happens? So let's see. Currently we are buying on day 1 and selling it on day 5, and we are making profit of $4. What if I buy stock on day 1 and sell it on day 2, and again buy it on day 2 and sell it on day 3, and again buying on day 3 and sell it on day 4? What happens? So let's see. If I sell it on day 2 and buy it on day 1, we make a profit of $1. Similarly, if we buy again on day 2 and sell it on day 3, we again going to make $1, so on and so forth. So if you look at this, both the calculation, you see that we are making profit of $4 if we are buying on one day and sell it on 5th day, and we are making the same profit if we are buying on day 1 and selling it on day 2. It means we are unnecessarily waiting for the stock to go up to its peak. We can buy it on one day and sell it on second day. But how this is possible? Well, we are already given stock prices in advance. Then we can simply find that will we making a profit on the next day or not, right? Because on day 1 the price is 1 and on day 2 the price is 2. So by looking at these two prices, we can easily calculate that if we buy stock on day 1, then will we be making a profit or not by selling stock on day 2? Because 2 minus 1 is 1. It means we will make profit of $1. So basically the idea is pretty simple, that instead of considering these long interval, we can simply consider the small intervals and buy and sell stock within this interval. And we can see that we are going to make the same profit out of it. Okay, but why we are changing the approach? The reason is, if we use this approach, then we have to write a lot of code. But if we are going to use this approach, then we have to write very less code, and we can make our code shorter and elegant. So let's see this approach once again, that we have to traverse all the day, and on each day we check if the next day is profitable or not. If the next day is profitable, then we book the profit, and on the selling day we again buy the stock and sell it on next day. And if the next day is not profitable for us, we simply move on to next day. This is the basic approach. Now let's see the implementation of this basic approach. So here we have this function maximum profit, and this function is taking prices array. We are initializing a variable maximum profit to 0, and then we are simply running a loop from 0 to less than price.length minus 1. Why price.length minus 1? Because we only want to check till 4th day, right? Because even if we go to 5th day, we cannot buy it, because if we buy it, we cannot sell it, right? Because there is no more upcoming day after the last day. And inside of this loop, we are simply checking if the price of the current day is less than equal to next day or not. If we found that the price of current day is smaller than the next day, then obviously we will make profit out of it. So if we found this condition, then we book our profit and add it to the maximum profit. Simple. And then after loop gets completed, we are returning the maximum profit. So let's dive into this code and see how it works. So we have this data 715364, and these are the stock prices of day 0, 1, 2, 3, 4, 5. We initialize the maximum profit variable to 0, and the loop begins with the first iteration, and the value of I is 0. We check if 7 is less than 1 or not. 7 is not less than 1. It means if we buy stock on day 0 with 7 price, and if we sell it on day 1 on 1 price, then definitely we are never going to make profit. Instead we will make loss. So better to ignore it. So we move to next day, and this day the value of I is 1. It means the day is 1. We check if 1 is less than 5 or not. Yeah, this time there are chances that we will make profit, because the stock price is 1 on day 1, and on next day the stock price is 5. So here we will make a profit of $4. So we book the profit and we move to next day. The value of I on next day is 2. So we check if 5 is less than 3 or not. This time 5 is not less than 3. So we simply move to next day. In next iteration, the value of I becomes 3, and 3 is less than 6 this time. So again we can make profit here. So we book our profit. 6 minus 3 is 3 plus the previous profit. 4 plus 3 is equal to 7, and then we move to next day. In next day the value of I becomes 4. We check if 6 is less than 4 or not, and 6 is not less than 4. So we move to next iteration, and in next iteration our for loop stops, because we do not have more days after the 5th day, and we are running this loop till 4th day only. And this is the maximum profit we can make if we buy and sell optimally. So far so clear. Now talking about the time complexity of this function, as we can see that we are running a loop from 0 to less than price.length. So the time complexity is going to remain same as the previous approach, that is big of n. and the space complexity is big of 1 because we are not using any extra space here. So both the complexity remains the same. But what advantage we get using this approach? Let's see the code of previous approach. See, we have written a lot of code here. And if you compare this code with this code, here we have written only 3 lines of code and we are done. So this is the main advantage we get using this approach, that our code becomes shorter and it also looks more elegant than the previous one. I hope you like this approach. So before we end this video, let's have a quick recap of what we have done so far. So we have been discussing this problem since 2 videos, and this was our last video of this problem. And in this video, we have discussed the optimal way to solve this problem using less number of code. So the problem was given as we are given an array of stock prices, and our task is to find the best time to buy and sell the stock so that we can make maximum profit out of it. So in previous video, we saw the valleys and peaks approach to solve this problem. And in that approach, we have written long code. And in that approach, the time complexity came out to be big of n and space complexity came out to be big of 1. And in this video, we saw the efficient approach to solve this problem. In this approach, instead of considering the longer interval, we are considering the shorter interval. And we are buying and selling stock on an alternate day to book the profit. And in this approach, we have written really short code as compared to previous approach to solve this problem. And the space and time complexity remains the same as the previous approach, that is big of n time complexity and big of 1 space complexity. So far we have seen 3 approaches to solve this problem. First approach was a recursive approach that we have seen in the first video. And in second video, we have seen that how we solve this problem iteratively using valleys and peak approach. And third approach we have seen in this video to consider the shorter interval instead of longer interval. And that approach is the optimal and the best approach so far. It requires less number of line of code, and also the code looks more elegant and simple to read. So I hope you understand this problem really well and you understand all the 3 solutions to solve this problem. So this is it for this video. Thanks for watching and see you in the next video.